Previously on Chemistry Z. We looked at the differences between atoms, elements and compounds. We also looked at how to name several different types of chemicals. And although it looked peak for our heroes when they attempted to write half equations, this isn't even my final form. Somehow our heroes were able to firm the onslaught of charges and subscripts. And after receiving the wisdom from the ancient dragon, Nandos, it all became light work. But our heroes now face 5 new threats: filtration, crystallization, simple distillation, fractional distillation, and chromatography. Will our heroes be able to separate these mixtures, or will they find the problem insoluble? Find out today on Chemistry Z. Here are the retrieval questions for this lesson. You know what to do. Reactants are on the left hand side of our arrow in both word and symbol equations. Compounds are 2 or more different atoms bonded together. Aluminium oxide is Al2O3. A mixture is a substance made up of 2 or more elements or compounds not chemically bonded together. Look at these 2 boxes. Use the definition to state which one is showing the mixture, and as an extension, state what the other one is showing. A is the mixture. B is actually a compound because it's made up of 2 or more different atoms chemically bonded together. The different atoms are represented by different colors here. The chemical bonds are these lines between the atoms. Mixtures and compounds have 2 important differences that you need to be aware of. First, mixtures have no fixed composition, while compounds have a fixed composition. What does that even mean, you might ask me? Well, let's tally up the different atoms that we have on both sides. On the mixture side, we have 6 red, 1 black and 6 blue. On the compound side, we have 8 reds and 4 black atoms. This can be simplified to a ratio of 2 and 1 by dividing both numbers by 4. We can't simplify the other side anymore without getting decimals. If I get rid of the same substance from both sides, let's see what happens. The mixture now has 4 red and 6 blue, which can be simplified to 2 red and 3 blues by dividing by 2. The compound side now has 6 red atoms and 3 black atoms. The reason why compounds have fixed composition is because this still can be simplified to a 2:1 ratio, 2 red and 1 black if we divide by 3. But no matter what we do on the mixture side, it will always change the composition. The next important difference is that mixtures can be easily separated without chemical reactions, but compounds require chemical reactions to change their properties. The rest of this video now will focus on each type of technique. The first technique, which you all probably done before, is filtration. This separates insoluble substances from solutions. Remember that solutions are made up of 2 things: a solute, which can dissolve, and a solvent, which does the dissolving. If something is insoluble, that means that it cannot dissolve in that specific solvent. A good example of this will be coffee. The coffee grains are made up of particles that are both soluble, which are the brown ones, and insoluble, which are the black ones. The filter paper has tiny holes inside it. At this moment, both the soluble and insoluble particles can't fit through. But look what happens when we add a solvent, in this case water. Solvents cause soluble substances to break down into smaller units. This then means that the solute can be separated from the insoluble substances because the solutes are now small enough to pass through the gaps in the filter paper. You will use filtration in your making salts required practical. The technical name for the solution that passes through your filter paper is called the filtrate, and the insoluble bit on the top is called the residue. We have separated the insoluble from the soluble, but what if we want pure dry crystals of our solutes? Well, that takes us to the next technique. Crystallization is when you separate soluble substances from a solvent inside your filtrate. In our example, that would be us separating the soluble brown particles from the water particles. To help us picture this, let's look at what actually happens when you dissolve a solute. I'll use table salt as an example. Table salt is actually made up of positive and negative subunits. These are called ions, but we'll look at that when we look at ionic bonds. When dissolved, water particles surround the individual charges, the individual ions, and separate them out. This piece of salt is in the process of being dissolved, but it hasn't completely dissolved yet. That's because we don't have enough water particles to dissolve the rest. When you have a situation like this, when you don't have enough water particles to dissolve your solute, we call the solution saturated. The more water particles I had, the more subunits dissolve. But we're not done yet. Crystallization is when we separate these soluble substances from the solvent, the water that surrounds it. Jaden, what can we do to separate the water from the salt particles?
Burn it.
You're technically right, but you're using the wrong key word.
Combustion.
No, you're going in the wrong direction now. Combustion is the scientific word for burning. You're absolutely right by that. But we're not burning the water, we're burning the fuel that heats up the water. So have another go.
Oh, we need to evaporate the thing.
Now you've got it. Water has a boiling point of 100 degrees Celsius. Virtually all salts have a higher boiling point than this. That means that if we heat up the salt and water mixture, we will evaporate the water and the solution will become saturated again, and that will leave the salt behind as it crystallizes. But what if we wanted the water and not the salt? That will take us to the next technique. Simple distillation is a technique used to separate a liquid from a mixture by evaporation followed by condensation. A quick reminder here. Evaporation is when a liquid turns into a gas, and condensation is when a gas turns into a liquid. This is the setup that you will have for simple distillation. You have a Bunsen burner that's providing the heat that will evaporate your solution. And then on the other side, you have a cooling mechanism that will turn your vapor back into a liquid. In this picture, it is just some ice cold water in a beaker, but you may be given this thing here. It's called a Liebig condenser. Water is pumped from the bottom and the water cools down the water vapor as it flows in the middle, and that causes it to condense. So that's simple distillation. Pretty straightforward. Fractional distillation is a little bit more complex, but rather than bog you down with details that you don't need for GCSE, it can just be summarized as this: a technique used to separate different liquids with different boiling points by evaporation followed by condensation. The apparatus that does this is something called a fractionating column. The context that you're going to see this in is in the refinement of crude oil. The plants are massive, as you can see here. Crude oil is a mixture of different hydrocarbons. Hydrocarbons are molecules made up of just hydrogen and carbon, hence the name hydrocarbon. The larger the hydrocarbon, the higher the boiling point.
Why?
Well, if you insist. This next bit of information is technically in chemistry too, but I'll do a quick little summary here. Chemicals have a special force of attraction between them when they get very close. These are called intermolecular forces. The longer the molecule, the more intermolecular forces that you have. Let's now imagine that it takes 10 degrees of heat energy to break one intermolecular force. What will be the boiling point of these two molecules? You should have clocked that the one on the left will be 20 degrees Celsius and the one on the right is 80 degrees Celsius. These aren't actually the real values, yeah? I'm just simplifying for you to be able to see what's going on here. So Tatiana, Where would you expect larger molecules to condense in our fractionating columns?
The bottom part is hotter. The larger molecules have higher boiling points. This means that they will condense closer to the bottom.
You are a genius! Here are the steps. The crude oil is heated at the bottom. Most of the crude oil vaporizes, they turn into a gas. The temperature is cooler at the top of the column and hotter at the bottom. The different hydrocarbons will condense at different levels based on their different boiling points. So smaller ones will condense at the top and larger ones, like Tatiana said, will condense near the bottom. Now that just leaves one more technique that we need to look at. Chromatography is a technique used to separate dissolved substances by running the solvent along a special paper. But I kinda clickbait you here, because I'm going to direct you to a video I did on the chromatography required practical where I go through this in ridiculous detail. So clickety click the card on the top to teleport over to that video there. And there we go. Lesson done.
Fatality.
Read the timestamps to skip to exactly where you want to go to. If you were stuck in any places, check the descriptions to check out some of the goodies that I've made, like flashcards and a revision timetable, and I'll catch you guys in a bit.